Hello friends, welcome back to the bench. So our patient is a hoverboard. We got it actually yesterday or the day before, and it was working fine. We actually enjoyed it. I left it to charge last night. It recharged, and today my son tried to work it, and it doesn't work. How does it not work? When you step on it, it just kind of starts jerking around, and it basically, in a way, it seems like there's too much power going to the motor, and the motor just flies. I suspected that probably the sensor, the position sensor, because one of the wheels just constantly goes back, regardless of the position. It should go forward when you lean forward, and should go back when you lean back. And all that worked yesterday just fine. So that was my suspicion. So I opened it up. We have very little electronics on this side. There's a battery and a little bit of electronics there, probably the level sensor or something like that. So the majority of the electronics is on this side, and that's where all the transistors are, right? Now, as I try to write it, it's after the basically catastrophic failure, the red LED starts lighting up or blinking, and something's wrong. I'm actually surprised how the feedback circuit works here, because it should have the output short detection, but it looks like it doesn't. So what I did, I just started preemptively measuring the transistors, right? Because it's very often that it's the transistor that's gonna burn and create a short, and that would explain the behavior. So I measured this one between collector and or a drain and source. Oh, come on. And oh, that's not this one. Maybe it was this one. No. See, now it's showing open line. Just a second ago, it was showing short. But now I'm thinking that it was showing short because the gate was still charged. Oh no, it's showing short on these two. Okay, because I don't know. Let's see. It should go gate, drain, source. So if that is correct, I'm touching between the gate and drain. Let's see the gate and source. That seems okay, because there's a reverse polarity diode inside, and drain source is fine. So it looks like we have a short between, oh, and now it's not showing. Something's not right here. Just a second ago I had a short on this one, but again, if the gate is charged, the transistor is going to show short, because that's this is probably IGBT module, not a MOSFET, because it's controlling a lot of power here. Let's reposition this so we can see under the scope. Oh, and actually the first fault that I found was this. This is power supply for the Bluetooth module, or the cables for the Bluetooth module. It looks like there's probably 5-volt linear regulator here. No, it's tip 127. I don't know. Maybe it is, maybe not. But this is soldered on directly to some resistor, some SMD resistor. Let me see if I can show it to you. So here's our wire that supplies Bluetooth module, and it's soldered on very crudely onto this 0-ohm resistor. All right, and the second wire detached from somewhere. Right, it broken off, so the rest of that wire should be visible somewhere. I can't really see where it came from, but it is it is crappy work for this kind of device. This is like really crappy work. What is this? The wire. I understand it's just for Bluetooth. It's, you know, it's going to work without Bluetooth, no problem. But still, you know, this is the device I would put a lot of effort to make it safe, and not just wire the, you know, the wire, not just solder the wires like that. And the power modules, or the power section. Yeah, so this is the gate. Okay, now I can see it. So we got gate, right? We have capacitor on the gate. So yeah, if this cap is charged and there's no discharge resistor on the gate, then drain and source could be conducting. That's correct. And so it's like the short that mysteriously disappears after a while when the transistor discharges. But and as you can see, we have 2 transistors per IGBT. These are most likely IGBT modules, and those control the transistor, the big transistor, right? Charge and discharge. So if we have a short, look at this one. It's crooked. This one's crooked too. This is really a low quality job here. The guy said that we paid like $40 for this, and the guy said that it was like $100 when he bought it or something like that. So I don't think we got a good deal on this, but I figured, $40, what the heck. Let's try it. And we had 1 day of fun with it. So I guess $40 a day, it's maybe a little steep, but what are you gonna do? And now at least we can see if we can fix something like this. So let's go to beeper and let's beep the transistors again. All of them. Okay, so this one is beeping, not here, but yes, gate to source, gate to drain, no, gate to source. No, this is going to be gate, yes, and so this should be drain, this is source. Typically that's how it is, right? And we have big cable over here. So that's unusual for the short to be between gate and source, but no short between drain and source. See? Now let's see, is there a diode? Oh, but okay, it conducts in this direction. That's why I read the short on it. Let's see, this one. Yeah, so it looks like, interesting. So it's short in one direction, right? In this direction, it's fine. It's open line. Well, I'm on the beeper, so this, open line means nothing. But this is dead short, 0, 0 in this direction. Now, even if there is a diode inside, we should not have a 0, 0. The diode mode should show maybe 0.6, maybe 0.2, 0.4. Typically it's around 0.6, but not that short. So definitely something is not right with this transistor. Now let's check all of them. Okay, few of them behave the same way. So is it normal? If I specialized in hoverboards, I would have the answer to that question. Is that normal? Should it be that way? But I am not. However, I have worked on quite a few devices that utilized big motors and had to control them with PID loop. I have never seen a transistor that would show short in one direction and no short in the other direction. As I said, if there's a diode inside, then there should be some voltage drop on it, not 0, 0. Let's test it with diode meter. Was in this direction. Yeah. Yeah, like this one is showing 1.5 voltage drop, right? The other transistor. And this one is showing negative open line. What is negative open line? The resistance is 0.0, like dead short, absolute dead short, but only in one direction. So is it shorted diode inside the transistor? So basically transistor works, but the diode is shorted. But if the diode is shorted, it should short in both directions, right? It should, yeah. Because if it's even if it's shorted in the way that it conducts only in one direction, that should be relatively fine. Because that voltage drop on the diodes is not something that we necessarily want. Ideal diode resists the current flow in the opposite direction, right? No current flows, and in the forward polarity, it behaves like a wire, right? It conducts everything in one direction and nothing in the other direction. So theoretically, that would be the perfect diode, right? And maybe it is correct. Maybe it does work that way, but I've never seen that before. So what we have to do is figure out how to get this board out of here and read what those transistors are. Once we know that, we can get the data sheet and we can test the theory. So let's see about that. Alrighty, I disassembled it. I have the answer. Now you might hear that I sound different because take a look at this. There, in OBS you have to put that microphone in every scene, otherwise it won't work. So anyways, this is Audio Technica wireless microphone, and I ran it through an ultrasonic cleaning cycle. I tested it with a bench power supply and it doesn't work. It turns on in a way when you supply 3 volts over here. It turns on, it starts grabbing about 35 milliamps, but that's it. The LED doesn't come on, it doesn't try to connect. It's weird. So we'll see. Now I'm gonna have to give it at least, I'm thinking 24 hours, maybe less, because there's a shield. This is now filled with alkaline and water and everything. So I won't be able to use this for a while. But luckily I have some spare microphones or a few other microphones to use. This one's also wireless, but this is lapel mic, which I don't like because every time you move, you know, the crinkling of the, yeah, plus it's far away from your mouth. Well, what are you gonna do? Typically I like when stuff breaks because I'm a repair technician, but I don't like when my stuff breaks because then I have to fix it. Okay, back to our case. So what is that transistor? You won't believe. It's a regular MOSFET. It's not IGBT. It does have, as you can see, reverse polarity diode, which I expected, but it's a regular fast, I think, Schottky. It will not give you a short in one direction. Why does it give you short in one direction, not the other direction? I've never seen that before. It's pretty weird. Normally, when transistor catches short, it's just like wire, right? And this one is a wire, but only in one direction. Now that is with the meter, right? Once you push some current through it, it could be that you know, that it conducts in both directions. But to be sure, we need to remove the transistor and measure it outside the circuit. If we see the same thing, we just need to replace the transistors, and that's actually pretty cool because they're like $3 on DigiKey, or actually you can use, I will probably replace it with different transistor. This one is 75 volt transistor, 80 amps. I will likely get much higher voltage because 75, this probably works on 48 volts, I would guess. Maybe 24, but I would think it's 48 volts because there's like a lot of kinetic energy that you have to produce. And so I will probably go as high as like 120 volts and maybe 100 amps, depending what I can find in the same package. Although I'm pretty sure I can change the package a little bit and just kind of place it over there. It should be fine. But first, let's remove it and see if it behaves the same way outside the circuit. Okay, we have the same behavior when the transistor is removed from circuit. The transistor seems to be fine. The reverse polarity diode is 0.4 voltage drop. It doesn't conduct in the forward, so we could also, you know, give it a few volts and see if it opens, closes correctly, but it looks like it's fine. Plus, when I measure the board right now, it gives me the same reading, meaning something else on the board is causing this. And again, it could be normal. Right? It's not necessarily that this is something wrong with the board. I mean, we know something is wrong because the board doesn't, or the device doesn't work correctly, and we know it worked yesterday. So it should be something related to power, or I would guess something related to power, not necessarily, but I would expect that, because that's pretty much all this device is, just a big power supply. Okay, I see nothing here, nothing that is suspicious, right? These two transistors are controlling this transistor. We have gate resistor and gate capacitor. We have caps for the drain. Yeah. And we have three big cables coming out from here. Each one of these three wires goes to one and the other motor, right? The left one and the right one. So we have two transistors per line, and it's basically three-phase generator. Since the transistors are fine, it is weird that it's just giving me short in one direction. But now I'm thinking that if I disconnect the motor, the short will be gone. It shouldn't be that the motor would cause the the short or perceivable short. No, it's still there. 0, 0. That is so weird. Why would that now with the motor disconnected? Could it be the battery? It's so unlikely. But so these, let's see, I won't be able to show it to you properly, but these three wires, 1, 2, and the third one is here, right? Yellow, blue, and green. This connects to our motor. So this is the left motor, and the feedback, let's see. So the feedback from the motor, where is it? This is the feedback from the motor. We have 1, 2, 3, 4, 5 wires, and they go here, and this is the LED that is blinking red. So if the LED is blinking red, then the brain of this device has detected that something is wrong. And typically when that happens, it's usually the feedback is wrong. Either the motor is consuming too much power, or not enough power, or the PID loop is out of sync. It needs to be tuned. That kind of stuff. So this could very well be an issue with a motor. Could be. This could have happened when this one wire, that's the ground wire that supplies Bluetooth, disconnected. Because when we got the device, the Bluetooth did work. You turn it on and the lady says that the Bluetooth is ready to connect. All right? It's not a part of the device. You really don't need it. for the device to work. So I don't think it's an issue. The Bluetooth not being there, obviously, but if we correlate it, when that wire disconnected, it could have caused some issues on the board. Okay, so here's my diagnosis. This sucks. Everything, the build quality, the components used, very simplistic approach to control circuit. There is some feedback, so at least that, and that's probably what's causing this to not work, maybe. But it hurt me twice. Once it just rammed into my knee when I put a little bit of pressure on it, and then it just started driving like crazy and hit my knee, and the other time it just ran away from underneath my feet. So it's pretty dangerous when it doesn't work. So I'm surprised that the feedback circuit is not just completely disabling output. It just, I don't know, it just doesn't perform the way it's supposed to perform. So what are we gonna do with this one? So what I was thinking, how it should be done, is connect the oscilloscope between the three phases, and let's see if all three phases are there. Because if one phase is missing, then yeah, it turns in the wrong direction, or it goes out of control. So I suspect that one phase is missing. But then I thought, to actually test that, I need to connect the wires to this, reassemble it, and have the wires outside. Then take the scope and have it in the battery powered, so I can use it in the field and step on it and see if all three phases are working correctly. And also see if the signal is correct, right? That would tell me which phase is having issues, and perhaps I can find the fault. But this is a $100 device. Do you think it's worth it? This is charging. Oh, yeah. Yeah, I can hear it buzzing. I don't know if you can hear this. The microphone might not be able to pick this up, but yeah. It could be faulty motor. Let's turn it off and let's disconnect. Let's disconnect one motor. But I'm pretty sure it's this motor that is having issues. But this one cannot be disconnected here. It's probably disconnected there. But let's disconnect the motor completely, at least one of them. And let's turn it on. Yeah, the same issue. Let's see what we have on the phases. Is there anything there? So one thing is that sound. This typically means, especially in power supplies, yeah, something's wrong. It could be the inductive element that is broken, that is faulty. It could be the capacitors. It could be the output issues, meaning maybe short or too much load on the output, and no load on the output, because that's just as bad as too much load on the output. So I'm not sure what to do with this. We do know that there is an issue, right? Soldering on these things is just absolutely awful. No cleaning. This thing here, I don't even know what it is. It's like, yeah, it's crap. It's really not even worth a repair. It's not even worth taking it apart. Yeah. All right, I'm gonna think about it still. I'm gonna put it back together. See if my wife can return it. Because one day is a little bit steep for a nice toy, but only one day of work, right? So it's a little bit steep. So I'll see if she can get our money back. It's only $40, so it's not a big deal, but still, I'm not in the position to just let it go. But that's it. If I think of something, I will post the update to this, but probably not. This is probably going back to the guy, or it's going to the trash. But I will remove a lot of stuff from it before I do, because there is some. I don't know. There's two motors. Hopefully, at least one of them is working correctly, and quite a few transistors and a big battery, which technically works. All right. Anyways, thank you guys very much for watching. I do appreciate you. And I shall see you in the next one.